In this video, we're going to look at the t-test or student's t-test. This particular test is used to determine if the means of two populations are significantly different from each other. To do a t-test, the data for one population needs to be in its own vector or own column in a data frame, and the other population needs to be in its own vector or column in a data frame. To start, I'm going to create a couple of vectors. So one vector is for non-smokers and one is for smokers, and we're asking if a particular measure of pulmonary function is influenced by smoking. So to do that, we simply use our t-test function, t.test, and we just give the two vectors that we want to compare. So we have non-smokers and smokers. And we run the line of code and we get our output down below in the console. We'll start with the very bottom line, so we can see that the mean of X, the mean for non-smokers, is 19.5 for this particular physiological measurement of lung function, and the mean for smokers is 17.5. So we do see a lower mean for smokers than for non-smokers. But is this mean significantly different? Is there enough variation between the groups to say that 17.5 is significantly less than 19.5? To determine that, we look at the value of t, and there's our test statistic associated with this many degrees of freedom. That's based on the number of observations that we have. And the value that we really want to take a look at is the p-value. And you can see the p-value is 0.09138, which is higher than our critical value of 0.05. So since this value is greater than the critical value, we accept the null hypothesis. The null hypothesis is that there is no difference between the two. The alternative hypothesis you can see here, which we cannot accept, is that there is a difference in the means. And in this case, the X would be greater than Y, but that is not statistically tenable. But we contemplate our experiment a little bit, and we realize that the impact of smoking should be to diminish lung function, but it certainly shouldn't be able to increase lung function. So our hypothesis we're going to revise now, and we're not going to test whether or not there's a difference between smokers and non-smokers, but we're going to ask, is the non-smoker function greater than the smoker function? So we're changing our alternative hypothesis. And to do that, we are going to use what is called a one-tailed test. We're only interested to know whether or not smokers are greater than non-smokers. So the alternative is to use greater here. So down below, we see that the value of X is 19.5 and the value of Y is 17.5. We want to know if this 19.5 is greater than 17.5. So we add this particular phrase here to our line of code, and that converts us to a one-tailed test. And we run that test. And what we find is a different result, that because we have used a more specific one-tailed prediction, our p-value is actually below the critical value of 0.05. So if we use a one-tailed test and expect that smoking is going to diminish our respiratory function, then in fact our analysis using that one-tailed test shows that that null hypothesis is false, and we can accept the hypothesis that smoking causes a reduction in pulmonary function. I'm going to call up a couple of data frames now. So we have data on two hibernating beavers. As you can see, the two data frames have shown up in the global environment there. Let's take a look at the head of one of them. And we can see that there are 4 columns day of the year, time of day, the temperature measured in Fahrenheit, and an activity code. So we are interested in what the hibernating temperature is of beaver number 1, and we're going to find the same sort of data for beaver number 2. So our question is there a difference in average hibernating temperature for beaver 1 and beaver 2? So to do that, we just do t-test again, and we need to just denote the 2 columns. So we have beaver 1 and beaver 2. And we'll use a regular two-tailed test for this particular test. And we get our output below again in the console. So we see that the average temperature of beaver 1 was 36.9 degrees Fahrenheit, and the average for beaver 2 was 37.6 degrees Fahrenheit. Our t statistic is quite large, and the degrees of freedom, again based on the number of measurements, is high, but the p-value is extremely small, well less than 0.05. So what we can do is to reject the null hypothesis here, and we can accept the hypothesis that beaver number 1 has a lower hibernating temperature than beaver number 2. Let's take a quick look at the size of these 2 data frames that we had analyzed here. If you look at beaver 1, we see that was based on 114 different measurements, but if we look at the dimensions of beaver 2, then there are only 100. But it's perfectly okay if we're doing a most t-test to have unequal sample sizes. So R was able to perform that t-test even though we had 14 more observations for beaver 1 than we did for beaver 2. Let's go to another data frame. We're going to look at the built-in iris data frame. And we'll take a look at the data in iris. So we have 4 morphological measurements that are based on structures of the flower. And what I want to do in this particular situation is to ask, is the sepal length, a structure that's just below the petal, is the sepal length the same as the petal length? Now we have different kind of data here than we had before because each one of these rows corresponds to a single flower. So what we're going to ask is sepal length minus petal length different than 0? So we're using what is called a paired t-test, that for every row there is a pair of data that we need to combine to do our analysis. So to do our t-test here, we're going to call our t-test function, and we're going to denote the 2 columns. Each column is a vector. So we'll do sepal length. And we're going to ask, is the mean of sepal length different than the mean of petal length? But this time, we're doing it in a paired fashion. So we need to say paired equals true. So we'll run this line. And we see down at the bottom of our analysis down here, we don't see the x and y value, because that's not what we are testing. We're testing for the difference between the mean of sepal length and the mean of petal length. So we see that the mean difference is 2.08 in a paired fashion. And if we go up to our t statistic, it's very large, 22. The degrees of freedom is high, based on 150 different rows of data, and our p-value is extremely small. So what we can do is to reject the null hypothesis and say that, in fact, there is a difference in the length of sepals versus the length of petals. And we can see from our difference here that sepal length is greater than petal length. Of course, if we wanted to know what those means were, we could just call them up independently. So mean of iris sepal length, so it's 5.84. And 3.78. So that's the difference of 2.08 you could see there.